Okay, chapter 9 in class exercise 1, problem number 1. Locate the centroid. That means find out the x bar and y bar for this shape. We are locating centroid, that is the geometric center of this shape here. Now, the xy coordinate system is defined, and this point is defined as like 0, 0, and the curvature has this equation y is equal to x cube. Okay, and we need to find the x centroid and y centroid of this area. So let's work on it. So the first thing that we need to do is we consider a small elemental rectangular shape or within the shape. So let's say for this small elemental rectangular shape, the width of that shape is dx, the height of the shape is y, so its area is y times dx, and its x centroid. So this is the centroid of this like small rectangular plate, which is located at x tilde is equal to x, and the y centroid is located as y tilde is equal to y by 2, which is the height divided by 2. So x tilde is x and y tilde is y by 2. So let's apply the formula for like calculating the overall centroid of the shape. So this is y times dx is the area. Now dA is y is equal to x cube. That's given to us. So we can substitute y is equal to x cube. So x cube dx is the area. X tilde is x and y tilde is y by 2. So to x centroid of the overall shape, x bar is integral x tilde dA divided by integral over area dA. So we can substitute this equation for dA. So it's integral x tilde times x, sorry, integral. Now x tilde itself is x, so we can substitute that here. So it's x times x cube dx. So this x cube dx is for dA, and x tilde is replaced by x, divided by integral x cube dx. And it's since it's integral over x, the limits are from 0 to 1. That's given here. So it's 0 to 1, it's 0 to 1, and then when we do this integration, so this will be x to the power 4 dx, so that integral will be x to the power 5 divided by 5. And then the limits are 0 to 1, and in the denominator it's x to the 4 divided by 4, and limits are 0 to 1. Okay, and when you substitute x equal to 1, it is actually 1 by 5 in the numerator divided by 1 by 4 in the denominator, so it's actually 4 by 5, and that is 0.8 meters. So that's the location of x bar, the overall x centroid of the shape. And then we do the same thing for the y centroid. So for y bar, it's integral, this time it's y tilde dA over integral dA. Now y tilde is y by 2, so it's y by 2, and dA is x cube dx over integral x cube dx, and the limits of integration are 0 to 1, 0 to 1. However, y itself is x cube, so we will replace this y by x cube, and we can take this 1 by 2 out. So this 1 by 2 is here, then it's integral 0 to 1. It's x cube multiplied by x cube times dx. So this x cube is because we have replaced y by x cube, and 0 to 1 x cube dx. So when we do this integration, this is x to the power 6, so its integral will be x to the power 7 divided by 7 in the numerator. So this is x to the power 7 divided by 7, 0 to 1 are the limits, divide by x to the power 4 divided by 4, and the limits are again 0 to 1. So when we substitute all these limits, the final answer is 0.286 meters. That's y bar, overall y centroid of the shape. So that's how we have calculated x and y centroid. So if we like to represent it graphically, then x bar is at zero point 0.8. So this is 1 meter, so it's 0.8 somewhere here along is the x bar, and y bar is 0.2, so somewhere here. So the overall centroid of this shape is here, which is x bar and y bar. Okay, so it's 0.8 in along x, but it's 0.2 along y. So that's the overall centroid of the shape. Thank you.